What if our solar system isn't as unique as we once believed? For centuries, we assumed the sun formed right here in this quiet region of the Milky Way and has remained here ever since. But new research is starting to challenge that idea. Using data from the European Space Agency's powerful star mapping mission, the Gaia spacecraft, astronomers discovered something remarkable. Scattered across the Milky Way are thousands of stars almost identical to our sun, nearly the same mass, the same age, and almost the exact same chemical fingerprint. Many of them even appear to share a similar journey through the galaxy, slowly migrating outward from the inner regions of the Milky Way over billions of years. In other words, our sun may not be a rare exception. It may be part of a much larger family of nearly identical stars that formed under very similar conditions. And that raises a shocking question. If so many stars share the same origin, the same chemistry, and possibly the same galactic journey as our sun, how many solar systems like ours might exist out there? And could any of them have developed life the way Earth did? Let's find out. The mystery began with something astronomers didn't expect. The sun's chemical fingerprint doesn't perfectly match the stars around it. Every star forms from a cloud of gas and dust, and that cloud contains a specific mixture of elements. When a star is born, those elements become permanently locked inside it. Because of that, astronomers can often tell where a star formed by studying its chemical composition. When scientists carefully analyze the sun's chemistry, they notice something unusual. Our star contains slightly higher levels of heavy elements than many nearby stars located at the same distance from the center of the Milky Way. Astronomers refer to these heavier elements as metals. In the Milky Way, the concentration of these elements changes depending on where stars are born. Closer to the galactic center, generations of massive stars have lived and died for billions of years. Their violent deaths scattered heavy elements into the surrounding gas. As a result, stars born closer to the center of the galaxy tend to contain more metals. And that's exactly what astronomers saw in the sun. Its chemical fingerprint looked more like stars that formed closer to the galactic center, not in the quiet outer region where we see it today. That raised a fascinating possibility. Maybe the sun didn't form where it currently resides. Maybe it formed deeper inside the galaxy and later migrated outward. To investigate that idea, astronomers began searching for stars that looked almost exactly like the sun. These are known as solar twins, stars with nearly the same mass, temperature, brightness, and chemical composition as our own star. If many of these solar twins shared a similar motion through the galaxy, they could reveal clues about the sun's past. To find them, scientists turned to one of the most ambitious astronomy missions ever launched, the Gaia spacecraft. The Gaia spacecraft is creating the most detailed map of the Milky Way ever produced. Since its launch, the spacecraft has measured the positions, motion, and brightness of nearly 2 billion stars. This incredible dataset allows astronomers to track how stars move through the galaxy with extraordinary precision. Within this enormous map, researchers searched for stars that closely resemble the sun. The results were remarkable. Scientists identified thousands of solar twins scattered throughout the galaxy. Many of these stars formed around the same time as the sun, roughly 4.6 billion years ago. But the most interesting discovery appeared when astronomers studied their orbits. Many of these sun-like stars appear to have migrated outward from the inner regions of the galaxy over billions of years. Their current positions suggest they were once much closer to the galactic center before gradually drifting outward. This process is known as stellar radial migration. Stars are not permanently locked into a single orbit around the galaxy. Gravitational forces from the spiral arms and the central bar of the Milky Way can slowly shift a star's orbit. Over immense periods of time, those forces can push stars thousands of light years away from where they originally formed. The pattern seen among solar twins strongly suggests that our sun may have experienced this exact process. Instead of forming in the quiet region where we find it today, the sun may have been born in a much busier part of the galaxy. Then, over billions of years, it slowly migrated outward along with thousands of other similar stars. But this raises an important question. If the sun once lived closer to the center of the galaxy, what kind of environment did the early solar system experience there? The answer may explain something even bigger: why life on Earth was able to survive. The inner regions of the Milky Way are far more dangerous than the region where the sun currently resides. Stars are packed much closer together, violent cosmic events occur more frequently. One of the biggest threats comes from supernova explosions, the catastrophic deaths of massive stars. These explosions release enormous bursts of radiation that can spread across nearby planetary systems. Powerful enough events could strip away planetary atmospheres or disrupt developing ecosystems. Near the galactic center, where stars are densely concentrated, these explosions happen far more often. Gravitational disturbances are also stronger there. Passing stars, massive gas clouds, and intense gravitational interactions can destabilize young planetary systems. Even small disruptions could send comets or asteroids crashing toward planets. Because of these risks, astronomers believe certain regions of the galaxy may be more suitable for life than others. Scientists call this idea the galactic habitable zone. Just as planets must orbit within a specific distance from their star to support liquid water, entire solar systems may need to orbit within safer regions of the galaxy to allow life to develop over billions of years. If the Sun migrated outward from the inner galaxy, its journey may have gradually carried the solar system into this safer region. Over time, the environment around Earth would have become calmer and more stable. Fewer nearby stars, fewer catastrophic explosions, more time for life to evolve. In other words, the Sun's long journey across the galaxy may have quietly helped create the conditions that allowed life to emerge on Earth. This new research suggests something extraordinary about our place in the universe. The Sun may have formed deep inside the Milky Way, in a crowded and chaotic region near the galactic center. Over billions of years, gravitational forces may have slowly carried it outward across the galaxy. Along the way, the solar system may have drifted into a quieter region, a place stable enough for life to evolve on Earth. If this idea is correct, it means our cosmic story is far more dynamic than we once believed. So here's the real question. Did the Sun's long journey across the Milky Way quietly shape the conditions that allowed life to emerge on Earth? And could other migrating stars be carrying life-friendly worlds across the galaxy right now? Drop your thoughts in the comments. I'm genuinely curious. If you enjoyed this video, don't forget to like, share, and subscribe for more updates on space exploration and scientific discoveries. Your support truly makes a difference and helps this channel grow. Thank you for watching, and see you next time.